to join, and then we're gonna start with this workshop. My camera is over there. Fantastic. I think we can start because like in the intro we'll have still some time for anyone to join us. Okay, cool. So hi guys. Today we're gonna talk about Chainlink protocol. The title of the session is Introduction to Chainlink Trust Minimized Services. Sorry. So I'm gonna try to briefly explain what Chainlink is, how the protocol works, which problems does it solve, and then I'll try to explain to you how you can use it in your own dApps, in your future projects, hackathons, whatever, maybe this one. And at the very end, we're going to have like a Q&A session. So if you have any questions, feel free to write them in the chat or unmute yourself during the Q&A session or whatever, and I'll do my best to answer them. So this workshop is going to last briefly around 30 minutes, 20 plus. We'll see about the Q&A session, but should be like pretty straightforward and easy to follow. Okay, so this is me. My name is Andrej Rakic. I'm one of the developer advocates for Chainlink Protocol Chainlink Labs. Here you can see listed my Twitter handle, my email address, in case you want to reach out afterwards, if you still have some additional questions, or if you want to talk anything Chainlink related, feel free to write me on Twitter. So my Twitter profile is publicly available. I'm mostly active there. So you can see me like writing about a bunch of Solidity stuff like that, blockchain stuff. So feel free to write me on a profile, like publicly, and I'll make sure to answer you even faster than via email. Okay, so the agenda I briefly mentioned. So today our three main topics will be the Oracle problem, will be decentralized Oracle networks, and at the very end, the Chainlink protocol itself. So first of all, to understand the Chainlink protocol, we need to go a bit back to understand the purpose of smart contracts, or even way back to understand the purpose of blockchain itself. So blockchain network, you probably heard about blockchain through Bitcoin or some other cryptocurrencies, basically created a mechanism for us to decentralize the current state of the web. Which means that now in like older internet, in Web 2, the most common architecture is so-called client-server architecture, where your client app, let's say that's an Instagram app or on a mobile or your web app or your desktop app, whatever, is gonna query and get some data from centralized servers and then display to you to interact via your apps, which is cool, like, which is really fast, handy. But the problem is that now data is in the hands of those centralized companies. You know, like when you have a monopoly on that kind of asset, let's say, like that data is, that's a problem for broader community. So that's the idea with blockchains and Web3 space, to decentralize that, I think. Now, when we had Bitcoin and all that stuff, and then came Ethereum, then came other layer 2 solutions, then came other virtual machines and other general purpose blockchains, like some others, like I don't know, like Solana or whatever. But basically, like Ethereum was the first one, and all of these layer 2 solutions to scale Ethereum. And the main thing that Ethereum brought was smart contracts. So the ability to write some general purpose code and general purpose applications on a blockchain, because with earlier iterations of blockchains like Bitcoin and stuff like that, you can, the purpose is just to send those cryptocurrencies, those coins. Bitcoin has like a scripting language, but it's not so powerful like Solidity is. So basically, Ethereum with its own virtual machine, which is EVM, gave us the ability to write general purpose programs on a blockchain, which is cool, which is why we are here basically on this hackathon. So the purpose of smart contract is essentially to solve the problem of trust. Like smart contract is just some computer code, like a fancy name for a computer code. Have a couple of lines of code, like a couple hundred-ish lines of code. It's not too big, it's not too critical. Like the idea is to put only necessary computation on a blockchain. Everything can be done. All of the other stuff can be done like in Web2 space. But basically those parts which lacks of trust, for example, needs to be on a blockchain. And this is what smart contracts gave to us. So the power of digital agreements. So what's the whole point? So we had agreements almost from the beginning of our existence, right? So, and agreements are all around us. Like if you make a Netflix subscription, that's an agreement. If you want to sell your house or buy a condo, another agreement, you know, like pay for your bills, phones, whatever. All of those are like agreements, right? And then the problem with traditional agreements, let's say, is the lack of trust. So with traditional agreements, there's always some kind of third-party operator which needs to take care of the correctness of agreements, let's say like that. So, you know, like if you want to get a loan from the bank, well, you need to, you know, like that third-party operator is bank, basically. That's how DeFi exists, for example, etc., etc. So the problem with those third-party operators and traditional agreements is that those third-party operators can have some common interest at some point. And, you know, like back in the days when there was like a great crisis in Greece, I think it was 2000 something the year, the banks didn't allow Greek people to basically get their money from bank. Like the withdrawals were limited to like 30 euros or something like that. Then a couple years ago, there was that website for trading game stocks options. And then when regular people wanted to trade those game stock options, basically centralized authorities behind the website, you know, like abandoned them to do that. That's not possible with cryptographically truth agreements. So on the right side of the screen, there is a so-called digital cryptographic agreements, basically a smart contracts with some additions. So with smart contracts, the code is public. The code is immutable and 24/7 live on a blockchain, which means that once the term sheets, let's say, are deployed to a blockchain, you cannot change it, right? That's why DeFi is so powerful. When we had those crashes of tax options, etc., those who tried to yield into DeFi, due to nature of the protocol, needed to pay the debt loans first. So this is like the true power of cryptographic agreements, because the rules are equal for all. Like the rules are known upfront and they cannot be changed. And everything is like cryptographically verified because it relies on blockchain and cryptography as underlying technologies, which is cool. Then like smart contracts has their own problems. So we know what smart contracts are. We know how to create dApps, but the problem with smart contracts is a so-called smart contract connectivity problem. What does that mean? Basically, when you deploy your smart contract to let's say Ethereum or some other general purpose blockchain, it can access a limited amount of data and information, so to say. So your smart contract can know like what's the block number or block time step current, like or the previous transaction, can maybe call some other smart contract on that blockchain, and that's pretty much it. Like smart contract can't know like what's the current weather in New York, in Berlin, in Tokyo. Smart contract can't know like who won the World Cup in football. Smart contract can't know what's the current price of any given cryptocurrency, which is kind of paradoxical because like we are in crypto space, but smart contracts can't know like what's the actual price of those assets. And that's the problem, because in order to create like DeFi protocols, you need that piece of information, like it's crucial for us. So basically, Chainlink in a way enabled DeFi, if you take a look at the past. But basically, this is the problem. Like smart contract connectivity, smart contracts can connect with data, with off-chain data, let's say, from outside the world. Okay. And now the definition of Oracle. Basically, Oracle is any given entity, like software, hardware, decentralized network, whatever, that can provide those off-chain data to smart contracts. And that's it. That's the pure definition of Oracle. It's like a broader one. But basically, like if you have your centralized server that can like provide some off-chain data. They can provide prices, for example, to your smart contract. It can be considered, and it is actually an oracle. And now we come to the oracle problem. So what's the oracle problem? We have all of this decentralized infra. We're on a blockchain. Everything's public. We're open sourcing our front ends. We're hosting maybe them to some, like decentralized storage networks, like, IPFS, Fleek, Filecoin, whatever. Everything is like decentralized. We're using wallets instead of like to log in with username and password, etc., etc. And then when we need price of data or a price of an asset or weather data or sports data or whatever, like we have only that centralized server as an oracle, right? And that's the oracle problem, because if you're using centralized solution, you're at risk to get inaccurate data or no data at all. And the solution to the smart contract connectivity problem now is Chainlink protocol. So what is Chainlink? Chainlink is a oracle decentralized protocol, like decentralized oracle network that can provide you off-chain data and computation in a secure and reliable manner. So, I'll explain you later, but basically with all of these off-chain data that are like provided to a smart contract, there's always a cryptographic proof that the data is valid. So this is basically, in essence, what the Chainlink protocol is. Okay, so I talked about it during the last slide, but basically centralized oracles are point of failure. So when you have like decentralized infra, data sources, whatever, and you have centralized node in the middle, you're at risk to get inaccurate data, or as I said, no data at all. So that's why the main focus for Chainlink is decentralization. So Chainlink consists of DONs. DON is short for decentralized oracle network, meaning that Chainlink node operators are part of the network. So anyone can spin up its own Chainlink node to become a node operator, to become part of the network. And then the network itself needs to reach a consensus before providing the final result. What that means is basically that Chainlink is, in essence, is not a blockchain, like there's no transactions, not like that, but it needs to reach a consensus. It's a decentralized network, basically. So decentralization means that full replicas are run by independent and Sybil-resistant node operators. And how it works? Let's say that you want to get the price of Ether. So on the right side of this picture, there's your smart contract, which asks Chainlink what's the current price of Ether. So all of these nodes can have its own source or sources of truth. Let's say one node can use only Uniswap, another node can use 3 DEXs and then CoinGecko API and some other. The third node can use 2 sources, etc. But all of these nodes need to provide their version of the current price. And then the network itself needs to run some powerful algorithms to reach a consensus and determine the actual price. And then that actual price will be given to the calling smart contract as a callback with cryptographic proof. So this is basically how getting the prices from Chainlink works, simplistically, obviously. So what are hybrid smart contracts? Basically, hybrid smart contract is any given smart contract that can provide both on-chain data and computation and off-chain data and computation. So like you have, like some on-chain logic, and then you have some off-chain computation or logic or data, whatever, combine them, and you can make really powerful digital agreements and dApps in general. So yeah, hybrid smart contracts are really powerful, but maybe your main question now where you're listening is like how to use Chainlink. So first of all, we have various palettes of services. The most important one and the most famous one for sure is Chainlink data feeds. So basically, I explained to you how Chainlink gets price data. That's it. So these are Chainlink data feeds. It powers basically a large amount of DeFi world. It basically enabled the DeFi world back in the days. So some famous protocols that are using Chainlink at the moment are Synthetics or Aave. Aave v3 recently launched. So basically, this is like the broader picture now of the previous previous slide, but on the top right is your calling smart contract. On the top left are data sources or exchanges, and this is the flow which describes in full how getting the latest price works. Basically, we have data providers, as I said, and Chainlink nodes can have multiple data providers, their sources, and then the network itself needs to reach a consensus, and then there is a reference contract on a blockchain. So Chainlink Dawn communicate with the calling smart contract with your smart contract through that reference contract, and that reference contract are basically going to create an on-chain transaction on a blockchain with the data, the price data as a callback. Why is that? Because when you run a new node on Ethereum, you need to sync with the rest of the network from Genesis block. And then during that syncing time, if you're asked like Chainlink again, what's the current price? Well, price can change, obviously. So you cannot sync, right? So this is the reason why we have that transaction on chain with the cryptographic proof of the computation, which I think is really powerful feature as well. So those were data feeds. How to start with data feeds? Just go to data.chain.link, see the available feeds. So this is the example of a website for ETH in terms of USD, data feed. So basically, you can see what's the current price here. You can see the Oracle sponsors. You can see like this data sources. You can see last update of the price, and you can see the heartbeat and the deviation threshold. So that's pretty much it. Like pretty standard stuff when you want to choose your data feed. You will see that depends on the network you are, on the blockchain you are. Maybe some feeds are missing. That's to prevent hacks and have those assets with low liquidity that can scam people. And also beside like crypto assets and tokens, there are some other feeds like proof of reserve feeds, meaning that you can have like a proof of, I don't know, gold reserve at some fund, for example. And my favorite are NFT floor prices. So basically for the top NFT collections, like, I don't know, BAYC or whatever, you can have the floor price coming from OpenSea and some other sources as well, like other NFT marketplaces. So I think that's a cool feature, and that's the feature that was asked a lot by actually you, the hackathon participants, the community, etc. We heard we saw a lot of demand. I heard a lot of complaints from them that they're missing the prices for NFTs. So we made it happen last year. So you can query the NFT prices as well. So basically, to finalize Chainlink data feeds, like we have full market coverage of both DEXs, CEXs. I explained to you. So feeds, as I said, live on multiple blockchains. You'll just need to go to documentation to grab the correct addresses for those reference contracts. And that's pretty much it. So, your smart contracts are going to communicate with the Dawn through that reference contract. And that's why I need to grab the correct address for each data feed. So ETH in terms of USD has like a different address than like BTC in terms of ETH, etc., etc. So if you go to the docs, it should be pretty straightforward because implementation is just pure copy paste with two functions, with actually one function, and that's pretty much it. So off-chain reporting, I forgot that, but off-chain reporting is a latest update addition. Basically, it saves us 90% of the gas, which is cool. Like gas savings are important. Okay, second one is Chainlink VRF. So as you may know, randomness on blockchain is tricky. So first of all, is public, meaning that earlier miners, now validators or MEV searchers, can front run and attack your contract if you're using on-chain randomness. So if you're using, I don't know, block hashes or block number, block timestamp, whatever, as an entropy for your randomness function, that means that you're basically vulnerable to replay attack and VRF attack and randomness attacks, sorry. So the second thing is that pseudo randomness thing. So when you're using, I don't know, in JavaScript, you have that math.random function. In essence, it's pseudo random. It's not truly random, which means that it's predictable. With the powerful machines, it's predictable. And it's okay. Like if you're having like an Excel sheet with, I don't know, 100 participants and you want to do some giveaway raffle, whatever, like Excel randomness with JavaScript is probably fine. But if you want to do on-chain randomness when you're dealing with actual people's money on a blockchain, that's not a wise idea. So that's why we have Chainlink VRF implemented. Basically, VRF standing for verifiably reliable function, meaning that in order to get a random number, you will need to cryptographically verify that the number is indeed random. And there is also like another contract in between, which have oracle.sol if you want to deep dive in it. But basically that contract has the ability to prove cryptographically that the value is indeed, that the number, okay, is indeed random before providing to the calling smart contract as a callback. What that means basically? That means that if you're using VRF and you requested randomness, if you receive random value in a couple of, I don't know, seconds, or whatever the time is, that means that number is truly random. That's it. If there is an error, you'll notice it, but that means that there was some issues. So don't worry about the pseudo randomness. It's verifiably provable, and you can actually prove it for any value on Etherscan as well. So this is basically what I was talking about. So if you have one takeaway that you want to give from this talk is that on-chain randomness is extremely dangerous, and that you should not ever do on-chain randomness with real assets, please. So on-chain randomness, extremely risky and easily to attack. That's why we came with the Chainlink VRF, to provide you a truly random numbers on a blockchain. And some notable projects as well are using VRF, like Pull Together and Avagotchi for like gaming, random threads, off-chain and on-chain lotteries, etc. But doesn't matter. This is really important. So on-chain randomness is extremely risky, extremely unsecure on a blockchain. Please don't do that. That's it. Okay. And finally, we have Chainlink automation. Basically, why there is a need for Chainlink automation. So this is like to do some decentralized event-driven DevOps stuff on a blockchain. So basically, smart contracts are passive by nature. So, to go from state A to state B in a blockchain, you need to initiate a transaction on a smart contract, right? So imagine that you're building some DeFi protocol that do some yield farming, for example. And you will need to call that harvest function multiple times. So first of all, that's really annoying job for a person, like to manually click all of these transactions to handle them, etc. Then it's with time zones and everything kind of gets impossible, right? And finally, like in a world in computer science where we tend to automate everything, why would you do that? So basically, the idea is now to have Chainlink automation, so Dawn that can automate your smart contracts. So there's two types of automation. The first one is time-based automation, like cron job on a blockchain. So you literally need to select your cron job parameters on the UI, so you doesn't need to implement anything in your code. Your smart contract is deployed somewhere, that's it. You go to the UI automation.chain.link, select time-based automation, using UI, select on 15 minutes, on each hour, weekly, bi-weekly, every third Thursday, on this date, particularly, no matter what. And then just sign a transaction and that's it. Like simple as that. And Chainlink will automate on a specific time interval frame, whatever, your smart contract. And automate means it's gonna call the function you tell it to call. The second type of automation is custom automation, meaning that you want to have a control over automation as well, meaning it's not dependent on time. To do that, also pretty simple. So you'll need to, there's like a automation compatible interface with only two functions, like you need to implement that contract. The first one function is check upkeep. and it's going to be in 90%, 99% maybe view function, meaning costs 0 gas. So check upkeep is going to be called from Chainlink nodes, from Chainlink Dawn on a regular time interframe, let's say on each block, or each 2 blocks, or each 5 blocks, doesn't matter, depends on chain. And check upkeep, we're gonna have a logic to tell the Dawn, do your smart contracts need automation? So Chainlink pings your contract to check upkeep, saying, do you need something from me? Do you need some automation from me? Your smart contract is gonna respond with Boolean value, true or false. False, I don't need automation, nothing happened. True, I need automation, and can additionally provide some parameters as well. So true, I need automation. Then the second function will be automatically called. And the second function is perform upkeep. Like Chainlink Dawn will manually call that function, perform upkeep. So your perform upkeep can be those Harvard calls or whatever your use case is, and that's it. You basically put your dApp on autopilot, and you're just enjoying the life, let's say. Cool. So where we've been, we're almost on time. So we heard about benefits of smart contracts. We heard about some Chainlink products. There are even more products that were announced at Chainlink SmartCon last year. So CCIP is coming, FSS is coming, Deco is coming. So all of the really cool stuff. So that will try to solve some critical issues on a blockchain nowadays, which are like MEV attacks, bridge hacks, etc., in a trust manner, like cryptographically proof and public. So that's pretty much it. We have a couple of minutes for questions, but before that, if you want to follow along, join our Discord chat. Documentation, your first station if you want to integrate Chainlink, so go to docs.chain.link. And if you want to have a starter kits, like a template repo for hackathon, maybe go to our GitHub organization, where you can find all of the hard starter kits, from Hardhat to Foundry to Truffle, Apex, etc. So that will be it. If you have any questions, feel free to ask. Okay, so the first one is how the off-chain data is getting to the Chainlink in a decentralized way. Basically, because I think I answered that, maybe the question came through during the presentation, but Chainlink consists of Dawn, decentralized Oracle network, means that let's say you have another middleware layer on top of your blockchain, in the same way that Ethereum have nodes to increase the decentralization, in the same way Chainlink has like decentralized Oracle network. Basically, node operators are gonna reach a consensus and provide data. So I think I spoke about that. How does Chainlink? What does Chainlink token do? Is Chainlink token required for querying Dawn? Yes. So basically, to incentivize the node operators or part of the decentralized Oracle network, so those nodes, to do honest computation, right? We need to pay them via link tokens. So that's so basically we are gonna pay them for their infra, for their computation that they did for us, like automation and stuff like that, in order to remain a part of the network, because we need more and more and more nodes to increase decentralization, right? So that's the incentive basically, and also like for doing the bad work. The network itself will punish you by slashing link tokens or kicking out of the network, etc. So that's the reason why link token exists. Please provide PowerPoint link. Yes, sure. I'll send it right now. Just stop sharing my screen. Sorry. Is weather data available for a particular place? Yeah, it is. So there is like I think Google actually are using our weather data for something. So just try to find it on our documentation. It's there. Share presentation. Anyone with a link, copy link, and paste it to the Zoom. Do you have any more questions? Sorry about this. Can Chainlink be used to retrieve cross-chain data? At the moment, no, but it will be with CCIP. So CCIP is announced. It should come really soon. I'm not sure about the dates, but with CCIP, that will be possible, yes. PowerPoint presentation link should be this one. I think we covered everything, right?
Yep.
Cool. I hope we're on time. I had a great time with you guys. Yeah. So
all right. Thanks a lot. Folks, if I think we're going to wait for, like, let's just say another minute or a couple of seconds before we close this out. If anyone has any questions, you can put your question here, or, once you start exploring, the Chainlink team would be available on our Discord as well on the Chainlink channel. So feel free to post your queries in case you come across any while building the Chainlink. I think someone has put a question in the chat box.
How do we connect external APIs using Chainlink? Oh, great question. So if you go to our docs, there is a section called Any API. So if you go to the docs, there's a section called Any API. Just follow the documentation. Basically, a way to create HTTP GET requests from your smart contract to the Chainlink. There is some boilerplate code as well there. Just don't forget to fund your contract with links, and don't forget, please, to write a withdrawal function, because links are going to be locked in your smart contract for any API.
Okay, maybe we can just take this last question.
Yeah. How much decentralization does Chainlink provide while retrieving off-chain data? So as I said, there's a lot of, I don't have like the exact number of DON participants at the moment, but we can see that on data.chain.link and some other analytics websites. So it's pretty publicly available to find that. Basically, we incentivize more and more people to join the network in order to increase the standardization. But at the moment, it's pretty reliable. So no major or minor hacks happened with Chainlink. And this is a good sign of decentralization. Finally, is the credit score for loan came into existence? I'm not sure, but you can check proof of reserve feeds on our docs, so proof of reserve, and see the available feeds. Maybe, I'm not sure. But with DECO, it will be. So DECO is basically a way to, with zero knowledge, to provide that you, I don't know, have a house in off-chain world, stuff like that. So DECO will be really powerful, but it's not live yet. So try with proof of reserve feeds.
Right, sounds cool.
Should I answer this one, or do we have time?
We have time. Like, it's up to you if you want to take this question.
Yeah. So what makes the random number provided by Chainlink PRF unique? How it differs? I have another presentation for that topic. Its answer is a bit longer, but basically you can ping me on Twitter, and I can link you like a paper, like a giant science paper, which describes how you can create truly unique number values. Because with JavaScript, you know that in computer science, based on type, for example, if you have like uint 256 or uint 16, even matters. So the range is like between 0 and 2 on 16 minus 1. So you have like a limited range of numbers, meaning you can choose your random number only from that range. And it's like pseudo randomness because it's predictable. But with true randomness, you can really come with any number in existence, and then you can scope it, etc. on your smart contract to adjust it. So just ping on Twitter. I can link you the paper, and it's not that simple to answer. But I hope that helped.
Sure. All right. Once again, thanks a lot, Andre, for joining the call. And I'm pretty sure like a lot of people are already looking at the questions. People are definitely excited to build with Chainlink. And really excited to see all the projects coming in.
Thank you. Had a fantastic time. Thank you, guys.
Thank you, everyone.
Bye.
Bye.